Okay, so yesterday in class we started talking about graphing y equals the sine of x and y equals the cosine of x, and we kind of just touched upon what amplitude is and what vertical shift is. Okay, so today what I want to do is talk to you guys about what happens if I go from y equals sine of x to y equals a sine of x plus c. Okay, and what we're going to do is vary what the a value is and what the c value is and see what that does to the graph. Before we begin, I kind of need you to recall y equals a x minus h squared plus k. If you recall that from parent graphs, this a value in front, okay, that always changed how quickly your quadratic increased or decreased, whether or not it opened up or opened down. That a value is going to do the same thing. It's going to stretch out the graph or smush the graph according to whatever that number is, and if it's negative, it's also going to do special things too. Okay, so this is going to affect the rate of increase of y values. Okay, if I translate that to y equals sine of x, this affects the amplitude. So it's either going to make the graph seem taller or shorter, flip it upside down. So it's still going to affect it in the same way. So that a value acts the same. Your c value, if you remember your k value on the end, this always affected the vertical position. So it affected where it began. Sometimes if you added a 2 on the end, it would shift it up 2 spaces. If you subtracted a 2, it would shift it down 2 spaces. But the graph itself would keep the same form regardless of what that value on the end was. So this affects vertical shift. Okay, and that is going to do the exact same thing in the sine of x plus c graph. That's going to affect vertical shift. So here, this is a change in amplitude, and then this guy over here, I don't know why that's not writing well, and then this guy over here is going to affect our vertical shift. When I graph the basic function y equals the sine of x, what I want to do is go out 2, 4, 6, and 8 spaces in both directions. 2, 4, 6, and 8 spaces in both directions. And what that indicates your quadrantal angles. I've got negative 2 pi, halfway is negative pi over 2, and negative 3 pi over 2. And in the other direction, it's going to be the same stuff, just positive. And what this does is indicate the quadrantal angles. The quadrantal angles are kind of critical points on a sine graph and also on a cosine graph. So we use those, we rely on those nice, neat values of 0, 1, or negative 1 to try and graph these. So I'm going to label these axes, and then I'm going to label the y-axis. The y-axis here, we're going to go up 2 spaces also just to make it neat looking, and I've got 1 and negative 1. So the sine function, if you remember, when you're at 0 degrees on the unit circle, you're at the point 1 comma 0. So the cosine is 1, the sine is 0. So at 0, the sine is 0. When I go up to pi over 2, I'm at the coordinate 0, 1, so the sine is that y coordinate, so it's positive 1. I go back down to 0 when I'm at pi. I go down to negative 1 when I'm at 3 pi over 2, and I go back up to 0 when I'm at 2 pi. And then that repeats just in the opposite direction. Your negative direction is a negative rotation, so if I'm at negative pi over 2, I'm really at 3 pi over 2. If I'm at negative pi, I'm at positive pi. If I'm at negative 3 pi over 2, I've gone almost all the way around in the opposite direction, so I'm at positive pi over 2. And then if I go negative 2 pi, I've rotated all the way around, and now I'm back at my starting place. So this is the graph of y equals the sine of x. Here she is, right there. Now let's look at what happens if I do y equals 2 times the sine of x. Okay, if you notice there's nothing being added or subtracted on the end, so all we're looking at is how is that 2 going to affect what my graph looks like. And if you think about it, it's not going to affect what x values I plug in because it's on the outside. Whatever I get for my sine, whatever value I get for my sine, whether that's 1, 0, or negative 1, I'm doubling it. Okay, so what that's going to do is affect my output. It's going to affect my y values only and not what values I plug in. Okay, so what I'm going to do is I'm going to indicate here. Here is negative 2. Here is positive 2. Okay, what I'm going to do is graph the regular sine curve, and then I'm going to think about, is that going to be at a distance of 1 or 2 from the center? The sine of 0 is still going to be 0. I'm doubling that, and the double of 0 is just 0. When I'm at pi over 2, the sine of pi over 2 is positive 1, but then I'm doubling that. Okay, so the sine of pi over 2 times 2 ends up being up here at 2. Okay, and then when I get to 0, 0 times 2 is still 0. When I get to negative 1 times 2 is going to double that. Okay, the sine of 3 pi over 2 is negative 1. I double that, so negative 1 becomes negative 2. Okay, and then 0 is not going to change. So what that's done, okay, that 2 value on the outside, what it's done is it's taken the distance that I am from that center, that median line, okay, it's taken the distance that I am and it's doubled it. Okay, because there's a 2 in front, it doubles the distance, just like it does with parent graphs. Now let's look at what would happen if that were negative 2. Okay, if I put a negative sign in front of that, what happens is it's going to flip my sine graph the same way that that negative sign would flip a quadratic or an absolute value or a cube. That still happens with sine curves. Okay, so when I'm at 0, multiplying 0 by negative 2, it doesn't matter, but once I get to pi over 2, the sine of pi over 2 is supposed to be positive 1, and we're multiplying that by negative 2. So now I'm taking the sine of pi over 2, I get 1, okay, and then I'm taking that and multiplying it by negative 2. So what ends up happening is I end up being down here instead of being up in the positive y direction. When I get back to 0, I'm still at 0. At 3 pi over 2, the sine of 3 pi over 2 is negative 1. I'm now multiplying that by negative 2. So negative 1 times negative 2 puts me up at positive 2. Okay, and then when I'm at 0, I'm still at 0. Okay, so what that's done, it's flipped my graph. It's made my graph go down first instead of going up first, like the sine is supposed to do. Okay, but notice the amplitude is still 2. amplitude is distance from your median line. Okay, and the distance from your median line hasn't changed. It's just that the direction that you travel for your pattern has changed. So your amplitude is still 2. The way that we calculate amplitude is actually the absolute value of A instead of just A itself. Okay, now let's look at y equals the sine of x plus 2. Okay, this guy is going to have a vertical shift. If you notice, the sine of x looks normal. It looks the way that it's supposed to. So this is going to be the exact same curve, just shifted up a couple of spaces. Okay, so if we're starting at the sine of x plus 2, that means that we're taking each one of our values and we are shifting them up 2 spaces. Okay, so what that means is at positive 2, that's where my new median line is. Okay, so this is actually going to take my median line and change it to be at positive 2 instead of at 0. Okay, it is still going to be the exact same pattern. It just means that my starting place is changing. So what's going to happen instead, you can do this very quickly. You can indicate, that same 2, 4, 6, 8 in both directions. 2, 4, 6, 8. Okay, and then we're going on a scale of 2. We're going up 2 spaces in each direction, but those just represent 1 unit. So now my amplitude is 1, just the same as the regular sine of x is. The only difference is that I'm beginning up 2 spaces from where I normally do. So when I go to graph this, 0 is now here, because once I find the sine of 0, I get 0, and then I add 2 to it. So my first point is 0, 2. When I get to pi over 2, the sine of pi over 2 is 1, but then I'm adding 2 to it, so I get positive 3 instead. So it goes, that also shifts up those 2 spaces. Then I'm back at 0. I'm down at positive 1 now because I'm shifting up 2 spaces from negative 1, and then I'm back at 0 again. So what this graph has done, it has taken the entire graph and it has shifted up 2 spaces. Okay, and you can see that going on right here, too. Okay, now let's combine this. Let's talk about changes in amplitude and changes in vertical shift. If you notice, this guy, that 1/2 sine of x minus 2, this guy is going to have a new median line. The median line is going to be down here at negative 2 because we're shifting down 2 spaces. Okay, it is still going to have the same period. There's no changes to the period at all, so we're still going from negative 2 pi to positive 2 pi to indicate 2 periods, 1 positive and 1 negative. The difference with this one is that we no longer have an amplitude of 1, okay, when we're actually at the sine of pi over 2, when we're at 1, we actually cut that in half, okay, and we get a half minus 2, we get negative 1.5. So when we are at pi over 2, we actually get negative 1.5, and you can check that out on your calculator if you don't believe me. Okay, but everything has shifted down 2 spaces, and then we've also affected the amplitude. We've gone down 2 and affected the amplitude. So now we're only going to go out a half from the central median line. So out a half, at 0, out a half, at 0 again. This is why it's important that we leave us some space, because you never know what the amplitude change is going to be. So now I have this shorter little graph with an amplitude of a half and then down 2 spaces from the origin. Okay, so now that we've talked about what amplitude and what vertical shift does, let's look at the cosine and see what happens when we make changes to the cosine, because we haven't graphed that yet. First of all, if I had y equals 3 cosine x minus 1, I would have a vertical shift that is down one space. So the first thing that I'm going to do is draw my new median line down one space from the origin. Okay, and now what I want to do is think about amplitude. Okay, another thing that you can do just to mark your place so that you don't make the mistake of graphing the wrong points, you can label out what your maximum and minimum values are. So if I'm at -1 and my amplitude is 3, that means that I'm going to go 1, 2, 3 spaces up. So I have my maximum line, and then 1, 2, 3 spaces down. So I have my minimum line. This way I can kind of visually see that I can't go past that point. So this is your 3 up, and this is your 3 down. Okay, so now what I'm going to do is try and graph the cosine. The cosine, as you know, when we're at 0, the cosine of 0 is +1. Okay, but this guy, we're tripling it. Okay, so instead of being at +1, we're going to multiply that by 3. So we're at 3 minus 1. We end up being at +2. So our first point is up here at 0, 2. Okay, my next point for my cosine goes down to the median line. It goes down to the axis. So my next point is going to go here. Okay, my next point when I'm at pi, I'm at -1. So I'm actually, I'm supposed to go down one space from the median line, but now I'm going to go down 3 spaces from the median line because my amplitude has changed. And if you check it out, if you do the cosine of pi, you get -1. -1 times -3 times 3 gives you -3. -3 minus 1 gives you -4. And it is 1, 2, 3, 4 spaces down from the origin. So we are in the correct spot. Okay, we're back up to 0, and then we're back up to the max. Okay, labeling that maximum and minimum, especially when you have something that's shifted, that's also got an amplitude change, is very helpful. So now what I'm going to do, now that I have the positive direction, I can just replicate it for the negative direction. I'm kind of mirroring what it would look like if we were to continue this in the other direction, and I've got the other half of my cosine graph. Okay, now let's do one more before we move on to talking about changes in the period. I've got -3 sine of x plus 2. Let's do that one. We just did a 3, so maybe we do -2. Sound good? I think so. Okay, so -2 sine of x plus 2. What that means is that my new median line is going to be +2 spaces up from the origin. So we're taking the entire graph and we're shifting it up 2 spaces. Okay, based on what we just did, you may want to label out that the minimum is now going to be here, and then the maximum is going to be up here. That way you don't go outside the parameters of your amplitude. So now the sine function. The sine function starts at 0, so it's nice, neat, and convenient. Okay, the sine function is also supposed to go from 0 to +1, because when I rotate 90 degrees to pi over 2, the sine of pi over 2 is +1. So I should be at +1, but when I take that +1 value for my sine and I multiply it by -2 and then I add +2 to it, I actually end up being at 0. Okay, you can think of it the long way as you're getting used to it. Okay, but once you get used to it, you can kind of trust it and then just, label those maximum and minimum values, and then you know that when we're at -2, when we have -2 for an amplitude, we're going to go down 2 first instead of going up 2, but we're going to have that maximum distance of 2 from the median line, and then we're going to go down 2. Now I'm going to go back up to 0 because that's what all the graphs do. I'm going to go up to my positive 2 distance from the median line, and then back down to 0. And then I'm going to replicate that in the other direction. So we're at a maximum, 0, minimum, 0. Okay, and now I'm ready to connect my dots. And this guy is the graph of -2 sine of x plus 2. Okay, so to talk about period, we have to introduce a new concept, really. We have to talk about this k-value, which was never there before when we talked about parent graphs. That k-value is a multiplier. What it does is it multiplies the angle. If I put a big whole number in it, what it's going to do is make the angle bigger than it is when I plug it in. If I make that k-value smaller, if I make it a fraction, it's going to make the angle smaller. So what that does actually is affect how long it takes me to go around in one rotation around the unit circle. If I put a multiplier in front of k that is a 2 or a 3, it's going to go around the unit circle twice as fast. So what happens is it changes the period. One whole rotation around the unit circle is your period for your sine function. If I'm putting a 2 in front of that, that means that by the time I get to pi, I'm already at the sine of 2 pi. Okay, so if, for instance, I had y equals the sine of 2 theta, okay, if I plug pi in here, I actually, let theta equal pi, I actually end up getting the sine of 2 pi. Okay, so what that does when I put that 2 in front of the angle, next to the angle, what it does is it either increases my angle or it decreases my angle. So it's going to either increase the amount of time that it takes to rotate around the unit circle or decrease the amount of time. And this is kind of the basic concept for how period is applied to graphs. So now there's a formula for a period. And you might not get this today, you might need me to explain this in person, but at least you're seeing some examples of it. Okay, the formula for period for any sine or cosine graph is going to be 2 pi over k. Okay, because that k value is going to either make the period much shorter or make the period much longer. Okay, so let's go back to graphing y equals the sine of 2 theta. Okay, as I said before, if I were to plug pi into this equation, I actually have the sine of 2 pi, not the sine of pi. So if I plug pi in, I'm not at the halfway point on my graph that I would be at if this didn't have a 2 next to the theta value. Okay, I'm actually all the way at the end. So what ends up happening, instead of having this nice neat sine function that goes up here and back to 0 and down and back to 0, instead of having this guy, what ends up happening, because we're already at 2 pi by the time that we get to pi, what ends up happening is I actually get a period that is half as long. Okay, so that means that I'm already at 2 pi, so I've already done that pattern by the time I get to pi. So I've actually shortened my period. Okay, so we don't want to get into the habit of always going from negative 2 pi to positive 2 pi if the period's different. Like I said, whenever we graph these, we're always going to be graphing one negative and one positive period. This is where the formula comes into play. So the formula is 2 pi over k, and here is your k value. So like I said, like I showed you before, when you plug in pi, you're already at 2 pi, so you've already gone all the way around your unit circle. So you can see that with the formula. When I do 2 pi over my k value of 2, I get a period of pi. So what that means is that one complete rotation is actually pi and not 2 pi. So when I graph using a period change, I'm going to go from negative pi to positive pi for y equals sine 2 theta. That way all I have to do is show one whole period, and I don't have to do 4 periods, 2 negative and 2 positive, just because my, my axes went from negative 2 pi to positive 2 pi. Okay, now that I have a new end value in both directions, my halfway point has changed. My halfway point is now pi over 2, because halfway to pi is 90 degrees. So halfway point is pi over 2. A quarter of the way is then pi over 4. And then this guy is 3/4 of the way. So now I've got negative pi over 4 and then negative 3 pi over 4. Okay, and then it's the exact same graph. I don't have any amplitude changes on this one. I wanted to just focus on the period change. So I still have the same sine graph. We're beginning at 0, max 0, min 0, and then min 0, max 0 in the negative direction. And I have the exact same curve, just different labels on the x-axis. Okay, so I don't have to do anything fancy because the period has changed. Okay, now let's look at what happens when that k value is a fraction. Okay, if putting a whole number in front makes your rotation around your unit circle happen faster. When we're at pi, we're already at 2 pi, we're going twice as fast. If I cut it in half, if every time I plug in an angle, I cut it in half, that means when I'm at pi, I'm supposed to be back at 0 for the cosine. I'm actually at, I'm supposed to be back at negative 1 for the cosine. But I'm actually at pi over 2, so I'm actually back at 0. So I'm cutting that angle in half. I think I've gone an entire distance of pi, but I've really only gone pi over 2 because I'm cutting that angle in half. When I've gone a distance of 2 pi, I've really only gone a distance of pi because I've cut that angle in half. So what that does is it slows down the process. Okay, that k value is going to make it take twice as long to get around the unit circle, and what that does is stretch out the period. It makes the period twice as long. So when I plug this into 2 pi over k, I have 2 pi over a half. Okay, and whenever I divide by a fraction, I'm multiplying by the reciprocal. So my period is actually 4 pi. Okay, so now when I go to label these axes, I'm going a distance of 4 pi in each direction. So 4 pi, negative 4 pi. Okay, negative 2 pi, negative pi, negative 3 pi. Okay, half the way is going to be negative 2 pi, a quarter of the way is negative pi, and then likewise pi, 2 pi, and 3 pi. Okay, and then I'm just graphing a cosine graph. I haven't done anything to change the amplitude, so that is all that I am doing. So I am beginning at my max, because that's what cosine does. I'm beginning at positive 1. I'm going to 0, hitting my minimum, going back to 0, and then hitting my maximum. And then same thing in the other direction, 0 min, 0 max. And then I've got my nice neat cosine graph that looks exactly the same. The only difference is the interval. It's very important on these quizzes that you label the entire interval accurately so that I know that you changed the period and that you're not just drawing the same basic graph. Okay, now that we've seen changes in amplitude, changes in vertical shift, and changes in period, let's put everything together. When you do have a problem that is this complicated, you do want to take notes. Okay, so right now for this problem, I know that my amplitude is 2. I know that the period is going to be 2 pi over k, so it's going to be 2 pi over 4. So my period is pi over 2. Don't get freaked out, they're just fractions. Okay, and then my vertical shift, there's a C in there, you just can't see it. My vertical shift is -1. So what that means is that my new median line is here. Okay, this guy is my new median line. Okay, and then I want to indicate where my maximum and my minimum are. My maximum is going to be 2 spaces up. Okay, there's my max. My minimum is going to be 2 spaces down. Okay, and then what I want to do is label those increments. Okay, I know that because my period is pi over 2. I know that halfway between 0 and pi over 2 is actually pi over 4. Halfway for that again is going to be pi over 8. Okay, and then I always like to add these two guys together. I'm adding pi over 8 and pi over 4. So I'm adding pi over 8 and 2 pi over 8. So I've got 3 pi over 8. You'll get the hang of those. Okay, so now I'm just going to replicate what I already labeled in the positive x direction. I've got negative pi over 2, negative 3 pi over 8, pi over 4, and pi over 8. Okay, they're negative though. Okay, and then now all I have to do is graph. I know that my sine curve begins. Okay, so now we have all the information. We've got our maximum and our minimum labeled. We figured out our period using 2 pi over k, and then we've labeled each of those 4 increments on our x-axis in the positive and negative direction. All we have to do is graph, and it is the same basic sine curve. We are beginning at 0, and then sine goes to its max. Okay, if you look back into the original problem, if I were to plug pi over 8 in for theta, I'm doing 4 times pi over 8 based on the equation, and I'm actually at pi over 2, so I should be at positive 1 for my angle value for my sine. Now I'm back at 0, and then I'm down at my minimum, and then back at 0 again. Okay, if you're ever unsure, second guessing yourself, plug it back in to the equation and see if you get the right quadrantal angle based on what you've already mapped out for your 4 increments. Okay, so now I've repeated it in the negative direction, and all I have to do is connect the dots, and I have the graph of my sine curve. We will practice more of these. You have a worksheet with a bunch of practice problems. Give them your best shot. Try 5 or 6 of them. Challenge yourself to do the ones with the more complicated period problems, and we will practice this again in class tomorrow.